Hi, welcome back to the third part of our Altium watch along. We're again joined by Jay, and
Hey everyone.
last time we kind of almost finished the schematic. We made an LCD screen symbol and footprint. We did some wiring things. Now we're going to do a little more wiring. We're going to make sure that we can program the MCU, and then we're going to start laying out the board. And once we do that, it'll kind of inform us on the things that we need to go back and change in the schematic. For example, what would make the most sense for the buttons, where we want to wire those up to, and also some other things. We have options on how the LCD screen will connect to the MCU. So we're going to decide that after we kind of see what the final product's going to look like. So yeah, let's worry about these programming ports. I have moved things around a little bit from last time. I'm always rearranging the schematic to best make use of the space, but otherwise nothing
and,
else has
and
changed.
increase clarity.
Yep. So we are going to. Can you talk a little bit about the programming for this particular chip? Because you know certainly more about it than I do.
Sure. So many ARM-based chips, and this is not a requirement, but use a type of programming called single wire debug. This is, I believe it's a subset of the JTAG standard, and basically it's a quick and easy programming protocol that lets you debug and upload to Flash, etc., on embedded chips. This requires 3 lines: clock, data, and an optional line called SWO, serial wire out. So all we need to do to program this is to break those connections out as into a specific part, and that's not official standard, but standard connector for this, and voltage and ground, etc. Did I miss anything?
No, I think that's fine. One thing I am going to do now is I think we finally have enough on the schematic to kind of break it up, and I wanted to show how to use these tools because it'll produce some very professional looking schematics. So if I hit the line tool and I hit tab, um, I just want to, while I'm doing this, go over here, we want to go to the properties of this line. Let me expand this so I can show what I'm talking about. I'm going to set it to medium thickness, and then the line style, I have a whole bunch of different line styles. I'm going to use probably dashed for this, and I will use red should be fine. Maybe I'll use a gray color just so it's not too distracting. And then I can kind of divide up the schematic, which I think can be a really nice touch on your schematics and break them into different pieces so that they're super readable. And I just want to do that because I was rearranging all these parts, and I finally feel like we have our schematic to a point where it's not going to change drastically from here out. It's probably going to look more or less like what we have at this moment in time, unless we go to add another IC. Um, and in that case, we would remake some of these lines. And you have some options when you're doing this, so I can push this here, for example, and now I can maybe make a standard where I put the title in the top left of all these boxes. And let me do that. I think that looks nice. What do you think?
I do that on mine as well. I think it keeps it really simple, and it means you also don't have to like search within that box to see what's what.
Right. I'm gonna call this
Uh,
input power management.
sure. Another cool advantage of using boxes is you can make an empty box, label it, and then like say that this is gonna be there later, or this is an optional thing we can add, um, but it's not here now, and that can like help you plan
Right.
for what you're gonna do. So like we might split this real-time clock box into two if we're considering adding another IC. We aren't right now, but if you make a version of this product, that might be a great place to add like an extra IC that speaks I2C or something. That could be like a battery percentage chip or vibrator for your wrist, etc.
Yep. The only problem I'm having is that these are not changing size, which is a problem I've encountered before. And I forget the trick to
Changing side.
fixing it. Yeah, well, you see, I want these to be size 24, like my other titles.
Oh, size.
Right now they are size 18, which is frustrating, and there's a
Oh,
reason that
small.
happens, but honestly, instead of figuring it out like I should, I'm just going to copy and paste a different title and change the words on it, because I don't want to spend a ton of time on this particular process. It's just a good practice and not much more.
In the end, literally no one will know if
Absolutely.
you just copy instead of correct.
No difference. This is what is this thing? Is the battery charging IC?
Yeah. Do we want the chip number or just the Oh, chip
It's in
number's on
there.
there. My bad. Yeah.
Very cool. Is this going to change size? Nope, I don't know why. Well, part of the reason that we're doing this video series in this format is to not hide the mistakes in the process of doing this. So just gonna live with it, and now you all know the secret. I don't know how to change the size in a already existing
Shh,
text, and
don't tell.
yeah, the
It's
secret's
just
out.
between us.
Yeah, the
Oh no,
secret's
so
out.
no.
And this is
Imagine if people on the internet knew. That'd be horrible.
yeah, exactly. I'd be so sad if someone posted this to YouTube.
Plus, it's always better to have a working to have something in front of you that is complete than to have something in front of you that's half complete, even if it's not perfect, right?
Yep.
So,
It is weird. I can select it and change other things about it. For example, I can select all of these and set them all to bold, and they all go.
well,
So I don't know.
that's odd.
Pretty weird. I
Mm.
changed my mind about these. I just want to make them black now because I can barely see them.
I
Cool.
often go with a solid dark gray.
Solid dark gray. Anyways, I didn't want to detract too much from the discussion about programming, so I think with
Mm.
this, let's get back into that.
Okay. Those are most of the considerations. What we will need to do is find an appropriate connector on Digikey,
Yep,
um, or in your case, manufacturer part search with fancy Altium tools. And then I will pull up a reference schematic because laziness. And when I say laziness, I mean work quick and semi-smartly, as opposed to exhaustively and incompletely. So I will find that and then pull up the schematic,
sounds good.
and we can Digikey search either together or at the same time.
Sounds good. I'll start looking. So we want yeah, what kind of connector is typical?
I honestly I don't know the name. I have it on my screen right now. Um, if you're able to switch over.
To show your screen? Yep.
Mhm.
Let me do that. Whoops, this is the previous episode. Let me switch over to your screen. There it is.
Okay, so these are pretty run of the mill. They're like a baby version of what you'll find on old ITE cables. Um, Often you'll find them called a box connector. Let's go to Digikey, and here we can see the pinout. What's cool is that they're keyed, so you can't plug them in wrong. If you've played with an Atmel Ice, it's the same connector. Um, I am honestly quite poor at finding connectors on Digikey, but let's try. It's so it is 50 mil pitch, I believe. So rectangle connector 10 pin. Oh, I still can't spell. Um, and when we're selecting part, we are going to select a part with this shrouding, the black plastic. And the reason we're going to select that is because it will make sure that we can't place it incorrectly and place it with too little space. So let's see, connectors, interconnects, terminal blocks, terminals. Any of this look right? Rectangular connectors. Nope. Chris, I think you're a little better at this than me. Where would you suggest?
Well, here, let me hop into Digikey at the same time as you and also start searching. Does the Adafruit page actually give any hints as to what the formal name of that part is called?
No, they do not. I'll check my personal components library in case I wrote it down. It is a 1.27 millimeter SMT box. That's helpful.
And it's surface mount?
Oh, yes, it is surface mount. So we want surface mount, and they come with these little pins in the bottom that make sure that when you plug them in, they're aligned. We might or might not want them, but we should keep that in mind. I forget the term. Board anchors, I think they're called. So many components will have board anchors, which are like little plastic nibs or specific shapes that must mate with the board in order for the component to be soldered on. So there's some for Yukon components, but Digikey doesn't stock those. So
Interesting.
I wonder if Mauser does, but we're going with Digikey for this project, so we'll do that some other time.
Is it a plug, receptacle, socket, or a header?
It's going to be receptacle.
It's 2 rows, and it has 10 positions. That looks pretty similar. It's through a hole.
Yeah. So that's. Ooh, what's the pitch?
2.54, yeah, it's too big.
Yeah. But you can filter for that, right?
Row spacing, 1.27.
And pitch mating as well. That would work. Go down a couple to 322.1.10.0.1.00. Is that SMD or no? Do you have SMD selected as a filter?
I don't think I actually do. Hold on. Let's look. Packaging. No, that's the shipment packaging. Hold on. Mounting type, surface mount. There's this one. I assume that plug comes out of the middle.
It does. That looks relatively correct.
Let's take a look. Interesting. Maybe the data
Do they have
sheet.
a drawing? Let me measure on my end the proper internal width. I have one in front of me that I will check. Just again, this is like an idiot check. Are we buying relatively the right component?
There's also this.
I have an 11 millimeter internal size for the width of the connector, the long way. If that makes sense.
Whoa, I backed up too much. These all look relatively similar. Yeah. You said it was 11 millimeters for the outside length here, dimension C.
No, not the outside. The dim B.
dim B, the
Should be
inside.
11.
The inside, okay.
Yeah.
So dim B. Uh,
9.83 is. I don't know.
no, 11.1
Oh, okay.
for the 10-pin version.
Oh, awesome. And let me check the other dimension of the inside. 3.39, so 3.4.
For the this way.
Yeah, dim.
No,
Oh,
3.4.
3.4. Yeah, yeah.
Cool. So this is the right connector.
Mm-hmm.
Oh, this is still your stream. Hold on. If I go to Altium, let's hope this exists or something similar exists. Oof. Well, they know about it. Let's try one of the other ones here because there's a list of them that all look to be identical. Right, because you got that one, but you also have all of these seem to be with some differences in the sides. That one's different. This one looks the same. Let's try
That
this
one
one.
looks through hole.
Oh, you're right. Darn it. That's the one we just looked at.
Yeah.
This is one that
Are
looks
you shooting for a lower price, or what's the shopping around for?
exists in manufacturer part search.
Ah, they tend to be pin-to-pin compatible because they're standard.
Okay.
Whether or not that's good practice, I can't say. I know if you look at the drawings and they're effectively the same.
So we could use this one that's all just the male pins.
The only difference is it won't have bounding boxes for where the connector ends.
True, but we can't add
Can
those.
well, we can edit them.
I don't know if I'm sure there is a way to actually edit the footprint of this. And actually, you know what we can do? I have an idea for how to do this. Let's place this and wire it as though it's the correct part, and then I'll show you how to do this correctly, like even better. So once you place this on the PCB, you can copy all of the elements in it and their dimensions to a new component without having to redesign anything in that component. And that's usually how I handle that issue.
Cool.
So that's what we'll do. We can do that now, or we can do that later.
Let's do it later.
Cool.
Have
So
you
then
have you
in that case,
demonstrated the skill before
yes.
online?
I don't think I
Yeah.
have.
Then oh,
No, that's not true. I did do it once when we did that breakout board tutorial. I copied all of the pins from my PCB into a footprint.
oh, then we're just gonna point you to go over there and watch that. It's pretty simple. Um, I'm sure you'll be able to catch on. Speaking to the audience, of course. Um,
Cool.
um, and let's take a look at the pin now. I'll start sharing my screen again.
I like having my pin 1 in the top left. So that's what I'll do here.
Let me check my library to see where we normally have pin 1.
And while you check that, I'm actually going to be right back in 1 second.
Okay, sounds good.
All right, I'm back.
Okay, so it looks like these connectors have a bit of an odd arrangement.
Okay.
I don't know if you can see my screen.
Let me put it on.
See, the pin numbering is non-standard. It goes 1, 2, 3, 4.
I do see that.
Yeah. Either way, pin 1 is on the keyed side. Is there a way where we can inspect the part and see that it's laid out the same way we want it to be?
Yeah, I think this might be the right time to put the PCB down and take a look at stuff like this.
Although we can also see on the symbol. But I agree. Let's put the PCB down.
All right, let's do that. So I'm gonna right-click on the project, add new PCB. This should be pretty comfortable stuff by this point. And then we wait for my old computer. And now what do we need to do? So before I can import my parts, I need to give them all designators. So I never gave them designators before on purpose because I want to. Oh, I gotta save my PCB. We're gonna call it main PCB. I don't know if there'll be others. Probably not. This is, I think, the only PCB we'll be designing, but it's a little more descriptive than just nothing but PCB.PCB. So we go to Tools, Annotation, Annotate Schematics, and then I get this window right here. And it should take care of it. Do I want to number right to left? Do I care? Not really. I think right to left makes sense because this should be 1, 2. It might get confused over
Agreed.
here, but I think it's fine. Update changes.
Honestly, as long as they're all unique, in my opinion, I don't mind.
So first I validate, all green check marks, then I execute, close, close. Now everything has numbers. There is an error here. What's this error? Yeah, so some of our nets only have 1 pin. That's definitely going to throw an error. That's okay though, we're going to fix that later. So then we come here, we go to Design, Import Changes. The only thing I don't want to add is the room. I will validate and I'll execute. And then we'll
What's
give
the
it a
room?
second. So the room is so that you can have different regions of your schematic or different schematics, and you can constrain them to only a certain area of the board. So you can make a room that includes all of the power electronics, and have a schematic that's just for power electronics, and then you have a different room that does something else, and then you can assign them to physical areas of the board.
Oh,
And it will
cool.
prevent you from moving them outside of those areas and getting signals and parts mixed up that you don't necessarily want to.
Hmm.
So
Do you know where the display went?
that is a good question. Where did the display go?
Okay.
So I found one problem is that I missed a pin. I had 2 6s and no 7.
And it didn't warn you.
It actually did warn me, I just didn't pay attention to it.
Okay.
So let's
How
edit
did it warn
this.
you?
Pin map, 7 to 7 looks good there. Now if I save that, let me try and compile it again. Interesting. Extra pins in net. Those are all from the other thing. Extra component. Compile successful. Okay, let's go back to our main schematic now. And let me try some things. So components. Let's place this component. If it's gonna let me. Hmm. Okay. Let me go back and make sure this is done correctly. Update changes, accept them, execute them. Cool. Save again. Okay. And there we have some issues there, but those shouldn't be affecting. So those errors shouldn't have any effect necessarily on making the PCB. They're just letting
Okay.
us know that some of our nets have some issues. For example, 1 pin floating inputs, things like that. No driving source for our certain pins. So it shouldn't matter too much. Let's go here. Let us add this PCB again. Here it is. Now I'm going to save it as same name as before. I do want to replace it. Import the changes. Breakout 0 right there. Let's try and validate this. Now it says check mark on that. And it says check mark again. There it is. Okay, so
Nice.
I guess my missing pin was preventing the library from compiling.
Okay.
So there you go.
We have to keep in mind when we're laying out our board, do we want the same hole sizes? Sorry, we might be changing the hole sizes in the future, but generally the same dimensions.
I think so.
Either way, sounds like it's pretty trivial to edit. So.
Alright. So now we can start thinking about how we're laying this watch out. And, you know, most of this PCB is going to take place under the screen. So we're going to try and, you know, constrain everything to under the screen. I'm going to move my reference point, origin, set origin, and I might just put it on one of these, you know, holes. But I'll put on pin 1. That's not, yeah, that is pin 1. Right there. And I will probably delete the text because it's going to throw errors. So to do that, I just want to point out that you need to unlock the primitives. So that gives you access to the things that make up this part once you've done that. And let's see. Oh, and I need to go to the top overlay layer, I think, to select that. Hold on a second. Yeah, there we go. So now I can select that and delete it. What I did is I went to this filter and I turned off component selection. So now, you know, usually when I click here, I'm going to select the entire component, which I don't want to do. So I undo that. Now I can't select the entire component, but I can click what's under it. Of course, I'm going to need it to move these parts, so I got to put it back on. And so yeah, now we're going to just start thinking about how to lay this out.
I think there are some things that we'll be mating with the case that we should take into consideration and place first, as well as maybe sketching out our dimension line for our dimensions for the beginning. I believe our dimensions will fill in the gaps that are currently between the mounting holes on this PCB because we need components to go right up to the edge.
Okay.
Or although we haven't accounted for the size of the buttons, so we might play that a little fast and loose.
One thing that I want to make it, you know, do, well, I guess we'll worry about it later. So I'm sorry, I was a little bit distracted when you were talking. Did you want to define the board shape?
Yes, but there are some things we haven't taken into consideration that might affect how deep those cutouts on the sides are. Because we're going to be putting our button cutouts on the sides, as well as our USB-C port.
Our button cutouts? You mean like
Our buttons.
this part where the buttons go on the side?
Yes. We have not, Chris and I have not taken the time to figure out exactly how we want to set our buttons into the casing this will have. And that'll affect our placement and how far they are from the edge.
That's true, but we can probably give it a rough guess.
Yes, so I guess that. I also think while we could add even one more button, so we have three on one side, one on the other, and then the USB-C port on the side with one button. Maybe like a total of 4 user buttons. That's
I like
also
that.
a well-tested user interface pattern. The pebble, all of the pebbles have up, down, enter, and then a back button. And I think since we're going for a watch, which only has button for input, no touchscreen, that would be a good choice.
Sounds good to me. So there it is. So you saw I got an error on that. I got an error because the designators are not matching. So the add component to class members, switch 4 to main schematic. Without switch 4 existing previously, it was thinking there was going to be an error. But after it resolved, I think this is how it works. After it resolves the add component, it can then resolve this error. So hitting execute actually changes the X to a check mark. So don't worry about it when that happens. And there's our new switch right here.
Awesome.
So we're gonna do
I have a
two on one
question
side,
about
one on the other.
3 on one side, 1 on the other.
Three on one side?
Yeah.
Oh, okay. I need
Up,
to
down, enter, and back.
need a fifth switch. And then I'll just go in, set that to switch 5, save it, validate. Actually think I can skip the validation step since I know there's going to be errors, but it's fine. I don't need the room. If I hit validate, I'm going to get that X. If I hit execute, I'm going to get a green check mark, and there it is.
I have a question
What's your question?
regarding the screen component we have. Are we looking at the front or the back of the screen board?
The screen board, we're looking at the top, so you can effectively think of this part as a socket that this fits directly down into.
Okay. Okay. Then do we want switches, 3 main switches on the left, and then other one on the right?
That's probably less. Well, it depends. I mean, do right-handed people wear watches on their right hand?
I'm right-handed. I wear my watch on my right hand, but that is not the norm. Most right-handed people wear their watch on their left hand and use the right hand to manipulate it.
So in that case, you would want most of your buttons on the right side.
Yes, I would agree. I've also talked to many people about watches, surprise. Um, and it tends to be perfectly fine that if you want to have the main switches on the other side, it's fine if it's a little odd, or if you switch to others, if you switch from left wrist to right wrist, you also flip the watch upside down so that the buttons are in the right place. And then you tell the settings that that is true, and it'll swizzle the buttons around. So I think that that's the right call to make.
Interesting.
Um, and shall we also drag the USB-C port in
This
there?
it keeps getting flipped. Yes, the USB-C port. I agree. I'll put switches. Well, I actually kind of would prefer them to go 2, 3, 4, just for wiring sake.
Out of curiosity, what's your snap width?
Right now it's 25 mil.
Okay.
Right, like that. Wait, one more.
Cool job.
Cool. USB-C
Is
is
the
right
one on the
here.
left a little farther down? That's the JST connector.
You are right. This is at negative 1300, and this is at negative. Oh no, I was looking at the X value. Whoops, 425. This is negative. Whoa. Oh no, I'm not grabbing the middle. Alright, I gotta zoom in to do this. Alright, the middle of this, let's put it at negative 450. It's easy to remember. Then we'll put this one at negative 450. And then this is 800, so that's a 350 difference. So this should be
Remember,
perfect.
total height is 17. So we would want the middle button halfway between.
You want
But
the
that's
middle
not
button?
accounting for the fact that the origin is 65 mil from the top edge. So one thing to keep in consideration if you're integrating a PCB into a chassis, review the hell out of it and have someone else look at it. Do you want me to do the calculation to find the middle point for the button, or we'll just save that for later?
I think I will save it for later. We're gonna move these anyways. My snap width is very coarse,
Oh, okay.
so I don't think this represents the final position of most things. But yeah,
Okay.
so that looks good.
Um,
This will be, well, it won't be flush with that. It'll be recessed. It should be somewhat flush with this, which is better.
yeah.
Now that
Uh,
MCU goes somewhere.
as far as placement, um, on board side, I think there's one consideration
Yep.
for two parts. The JST connector will be on the bottom, and the programming header will be on the bottom.
So to flip the JST to the bottom, we'll hit L. Now the pads turn a different color. By the way, your PCB editor, if you're using Altium, is going to look different from mine. That's a guarantee because I have custom colors on some of these. I tend to like slightly more purplish blue type color for the top layer, not orange for the bottom, which is not by default you get Spider-Man colors, which I don't personally like. Easy to change. You just go to your preferences up here. You'll get a window. You can go to PCB editor and change the defaults for all kinds of different things. So display, general, I don't know, there's a bunch of things in here. Just look through them. You'll get color options. Layer colors, that's what I changed. There you go. Just so you know. So yeah, this is flipped to the bottom. This is our JST connector. You said the programming header was also going to be on the bottom.
Yes.
And that is this part.
And we might want to take into account the width of the body of the connector at this point soon. When we go to place them.
Right, which is the point of even making the PCB to begin with.
Oh, right.
Yeah, so I'm not doing anything too crazy right now. What is this? Is U4? I forget what this part is. It's okay if I click on it.
Charger, probably.
This is the voltage regulator.
Oh, regulator. My bad.
And if I click on this, this is the battery charging controller. So I probably want to keep that somewhere near the JST connector or somewhere.
You could also put it along the bottom edge, as I'm guessing that's where it'll end up being.
If I zoom in on these, I'm going to get some information about where the out is. So that 3.3 volt is the out. So if I flip this around, now the out is facing up, which should be fine. Again, these are going to move. It's a promise. This is the MOSFET to switch the input power, so we'll keep that somewhere near the USB for now. These are going to go. This is a good question. Is which way?
Along the bottom edge.
This points, yeah, bottom edge.
Facing either left or right, I think.
Let's face inwards.
Move it over and then put the JST connector to the right of it if it's facing that direction.
You want me to put the JST connector facing?
Oh, sorry. The programming header would go, if it's positioned like that, I think it should go to the right of it. Although we'll need a little more space for when we figure out the width of the connector box. Other side.
The wires, I believe, plug in like this. These are the mounting holes. So you don't want this to be blocking the connector.
They plug in on the other side. They plug in from the left to the right.
Really?
Yes.
Oh, okay, I see why. Yeah, that's the front. Yep, okay. Yep, I had it backwards. Cool. Yeah, so we're going to change this up in a moment.
And of course, we'll go back and add all the right pinouts as well once we figure out that stuff.
So you guys are probably noticing that everything's green right now. It's because I'm getting errors on everything because I have a part inside of a part, which is, well, actually, most of my errors have to do with the silkscreen passing through different parts. I'm getting silkscreen errors and all kinds of things like that. So how do I fix that? For now, I am going to just reset the error markers. That will delete them for the time being. Then I'm going to use this to define my board shape, and then I'm going to just get rid of this part for now and worry about it later, because I don't really even want the screen blocking my view at the current time. So what I'm going to do, if it's okay with you, Jay, is define a rectangle. That will be our board, and it'll round the corners. So let's do that. So how do I do that? I press 1. Now I'm in board editing mode. Let's go to... actually, I want to do this a little differently. Some manufacturers are going to ask you to define the outline of your board on the mechanical layer. So if I go back to, I press 2 on my keyboard, and I go to mechanical 1, which is where you would do that. Now I can actually start drawing that. So now I'm drawing right in here. I'm going to bring this over until it's in line. Click there. I can't see anything because it's being blocked, so I'll hit Shift S. Now that layer is highlighted, although the color is kind of dark. maybe I can go into my colors and make it a brighter color so it's easier to see. Mechanical layer 1. What color can I make that that's pretty obnoxious, like this pink color? Maybe. Do a custom color. Can go a little brighter on it. Something like that. Oh, maybe this, like, that's pretty different from anything else I have. Let's try that. Yeah. So now that blue, that light blue is my mechanical one. So where else can I go? I'm going to go here. So why am I doing this instead of defining it the other way? You're going to see why in a moment. There's a very, very handy tool that is going to make it easier to radius the edge of this board. I'll show you how to do that. Click there. We come in. Now we use the arc. So if you just define the board the typical way, I think I want any angle on this. Is that what I want? Nope, that is not what I want. I can just use center because I have the center of these. This is my start. This is my end. And of course the size of this is wrong. Cool. Yeah, so I can draw these radiuses. And by the way, another way to put this in different places is to copy it from its center. Then I have the option to rotate it. Cool. 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 Alright.
Select.
Now I'm going to multi-select all of these lines. And I can redefine the board shape from selective primitives. Right? So design, board shape, define from selected objects, boom. And there it is. So we've now cut the board down
Nice.
to just the right shape. And that's better than doing it the other way for those radius corners and stuff, because if I do it the other way, I don't get that option. All I get to do, if I like redefine the board shape, is do these like sharp corner things, which can be fine. But you know, you're going to end up with something that doesn't have those rounded corners, and that's terrible. So for a professional board like this, it's nice to have the rounded corners. The manufacturers have no trouble doing that anyways, so you might as well. And that's it. So it looks like we're good. So I'm going to go back to the
Perfect.
top layer. And now that I've done that, I know where I'm allowed to place my parts without the need for that screen to be throwing errors and blocking other things. So let me get rid of
Um,
that for now. Although I do have to be
we
careful for
might
the mounting holes.
we might in sync the connector and buttons by a couple millimeters in the future, but as long as we leave space near them, we should be perfectly fine.
I need to unlock the position and put it over here. Yes. So we'll move that over and keep referring to it to make sure it's okay. And it should be easy to do that right now because I have the origin set here. I know that's my mounting hole, right? So
And you also know the radiuses will line up as well.
yep. Cool. Okay, so now we can proceed without all of the error marks in our face while we're trying to work.
Is it hard to add silkscreen to this?
Not at all. To do that,
Could we move the part back over, add some silkscreen notes to ourselves, and then take it off?
sure could.
Like just very rough outlines around the mounting holes and or most importantly, the holes up at the top, the headers.
Alright, so where do you want to add the silk screen? So I'm going to come down here, I'm going to choose my top overlay, and I'm ready.
Okay. Just a block like starting about in line with the cutout line, if that makes sense.
Okay, and what am I trying to denote here?
We're trying to denote where the holes for the headers are, so that we don't put components on top of them.
How about if I do this, and that even lets me know where that notch is too.
Yeah. Sorry. Maybe 25 tick down, just because there's going to be a little plastic surrounding those. Not much, but won't hurt. until we know the exact component we use to connect it.
Select these. My grid is 25. Now I move it one move down, and there it is.
Perfect.
That's all?
Uh, do we want to do the same on the bottom or no?
No, I think it's okay. We know that these are going to be here.
Okay.
So yeah, let's grab this, move it over. Cool, so now we have that, and we know that is the hard limit for placing components. And this board shouldn't honestly be too hard. It's actually not as crowded as it might look. The reason is, you know, if we have an emergency, we can stick something on the backside, and we probably won't even have to. So I guess the reset switch will go closer to the microcontroller.
Oh, we'll want to be able to reach it from the outside. Um, right? By sticking a pokey thing in. So we need to make sure it has a clear line of sight to the outside of the board. We could put it to the bottom of the USB-C port, even though that's a kind of a weird route for a reset line.
I'm going to preemptively rotate this because I know it'll
Would
be
you like to
trouble.
rename SW1 to RST?
I can, and the way to do that is to go back into the schematic and actually rename it. Because that is
That's
its
how we do it in
designator.
Eagle as well.
Yeah, it just pulls right from the designator, so that's right here. Switch 1, and we are going to change that to RST, save it, and in the board we can import the change. Done.
Awesome. Also, can we move the USB-C port out so that anything except the hole is like sticking a little out from the board? Oh, so that pink line is in line with the board outline?
Okay, so I move it back.
No, see how there's a pink line right below the stalk of the J?
Yep.
I'd say let's line that up with the board edge.
Alright, so now we're going to get into a smaller snap. And there it goes. Cool.
Oh, again, we might revise this a little in the future, or in fact we will, but
there are some things that are kind of pretty much set in stone at this point, which is going to be not set in stone, but like it's the positions of these switches probably aren't going to change. The USB-C port probably won't change very much. The things that will change might be the placement of our passives as we route. And when it comes to placing components on the board, I don't want to, give the wrong impression, but you can be a little more. If it's your first time designing boards, I urge you to not worry too much about routing. The thing about routing the board is you can probably make it work. If there's room for the silk screen around the components, there's probably room for the traces, unless you have something really crazy and dense. And if you do, then you might need to do a 4-layer board instead of a 2-layer. But in the end, you can probably do it.
and keep in mind that I totally agree. And also that is for most general designs. Most stuff we're going to be doing just generally, we don't require, very high precision timing. We don't require megahertz, gigahertz clocks. Sorry, hundreds of megahertz or gigahertz clocks. But if you're wiring RAM or something for PGA, you do have to keep that in mind. But for this kind of stuff, generally you're fine. Also, to Chris's statement about things being locked in stone, I agree. For the most part, we're not going to be moving the positions of any of these. At the most, we'll move the user switches in a millimeter or two and then add little cutouts so that the buttons you push them with are flush, but that's relatively simple. So before we finalize placement of other components, I had a thought. We know that we're going to need to connect the USB pins from the SMB51 to the USB port. So what if we could do that in the schematic and then see what side of the chip they're on and rotate that to work well?
That sounds good. I do just want to do one thing before we leave, which is I want to adjust the rules. So this is a scary menu that you get by going to design rules ... and then you get this. this is what Altium's constantly checking for while you're designing, and we don't need all of these right now, which is why we're getting a ton of errors. So we technically do care about component clearance, but I'm going to shut it off for the time being because we're going to get errors between the screen and the rest of the boards for the things that we know aren't going to be problems. We'll turn it on again before we finish everything to make sure everything else is okay. And there was keep out rules that I was wondering about too. We just apply these for now. Yeah, so now that went away. Um, this isn't happy because of how close it is to the edge, I believe. This is a keep out region. Now the keep out region is overlapping with a mechanical layer, which I think is the problem. I could be wrong about that, but in the end, we know it's not going to be an issue, so we're going to shut it off for now and turn it on again later. So you were saying we should go back to the schematic?
Yeah. So we know that we're going to connect data plus and data minus pins to the MCU. We also know we're going to connect power pins and ground pins. So while you connect power and ground, I'll look at what pins require data plus and data minus.
Sounds
and
good.
get back to you. Okay, I'm ready when you are.
So I want VDD ANA, VDD core, VDD
BDD
IO.
core is not connected to power.
No?
No. BDD core is connected differently. And we'll say that for
For later.
later.
What about
Add a
VDD
comment.
IOB?
I believe that's power.
Alright, we'll have to double check that.
Where I'm checking, there's no IOB. It's just 0, 1, 2, 3.
Do you know what
Um,
VSW is?
uh, yes, voltage switch. So this is chip specific. The AT7051 has two options. So two options for power configuration. So the way this chip works is the ARM core inside of it runs at 1.18 volts, but the rest of the chip, the GPIO and the outer IO ring, functions at 3.3 volts. So the BDD core is the voltage line that has the 1.18, if I remember correctly, volts on it. And you can either use an internal linear regulator or an internal switching regulator for this. And we'll need to do a little more look into the datasheet and see which one we want to use. And then we'll have to configure fuses for that as well. But we're going to leave those blank for now and put a comment on the schematic saying, go check datasheet for this kind of stuff. For power configuration pin.
For this one as well?
Yeah.
Cool.
Okay. So data plus goes to PA24, which is physical pin 45.
That's not what I want. I want a net label, tab, right align, and this is data plus. PA24.
Mm-hmm. And then 25 is data minus.
Let's click this. Now it's data minus.
And I have two more for you right after that.
Go ahead.
PA30 is going to be SWD CLK, which is single wire debug clock.
SWD CLK.
And then 31 is going to be SWD IO. I do it without an underscore. That is personal preference.
I'm not going to do it with an underscore because earlier I used hyphens, and I hate mixing the two together. It's not very consistent, so I'll just use nothing. And that's good enough.
Okay. One more, which is, where is it? Somewhere. It's the single wire out pin. It's the optional pin for the debugging interface. I was having trouble finding it. Possible it's not broken out on the reference schematic I'm using. But let's move on to connecting that to the header for the programming port.
Yeah,
Programming pins.
let's oh wait, this
Let's
is the
tackle
correct.
that, and I'll find
This is the
what
correct numbering for this, right? 1, 2, 3, 4.
it is. Let's go check out the PCB and double check.
Okay. On the PCB, 1, 2, 3, 4. Yeah,
Cool.
5, 6 jumped around.
And the key is going to go on the side with the dot because it has pin 1.
Nice.
Do you see a bunch of pink artifacting on your screen as well?
The pink around all of everything.
Yeah.
That is the solder mask
No.
expansion.
Oh no, it's compression artifacts.
Okay.
Through Discord. Okay. Let's see.
I can hold control and press the middle mouse button and then move the mouse. That's the smooth zoom in and out. I just thought I'd say that in case people haven't been used to using that. It can be a little handy to get a exact level of zoom that's more.
Okay. Serial wire out is pin 59. Physical pin 59, also known as PB30.
Okay. PB3059. Yep.
And naming choice is up to you. I tend to use just SWO, but you could also use SWD, SWO, which is redundant but more consistent.
I'm going to use SWO. Cool.
Okay. I'll pull up the pinout for that connector, and after that we can tackle the physical box size. There's a question.
Sure.
Okay. Opening up my library. Okay. And last check. Okay. Looks like. Oh wait, I can just go off the Adafruit website. That's faster. Okay. So pin. Oh, that closed. Sorry, my computer crashed. I had everything pulled up for
Oh
quick
no.
reference. When it crashed before, of course, it's Adafruit. So what I'm just going is I'm going to adafruit.com, and I'm going not because you can't find this elsewhere, just because this is the fastest way to do it, because I know what we're looking for. Okay, so with the key on pin 1 side, top-down view, pin 1 is VREF,
Right. VREF.
which we're going to connect to 3.3 volts.
Yes. Next.
Then we have 2 grounds.
Which are what pins?
3 and 5.
3 and 5. I just used this port for a project not that long ago. Okay.
Okay. And then a key pin, which we're going to not use, but should still be labeled key.
I don't want to give it a net label. So I will just put some text next to it.
For reference, for anyone out there, this is a part I often use a lot. So what I did is I made a footprint, I made a symbol that has these names on the pins as opposed to just the numbers. Kind of like how a chip will have that as well. That way you have the pin number and then the name. And you don't have to like think about or reference something else, it's right there. And you idiot check it while you're making that. And then you ask someone else to check it as well, of course. Pin 9 is called ground detect. I remember you saying something we had to do specific with that.
I believe we connected it to ground.
Okay, that's what I normally do with it.
Yep.
But okay. And then starting from the top right, going downwards, we have SWDIO.
Tab, right align, SWDIO. I meant left align, but I said right align. Next.
Clock, SWD clock. Then SWO. Not connect, and then reset. Reset of the main chip, I should say. Is that what we named it?
I don't think we even give it a name. We'll do that now.
Let's do that. I normally go with a full word reset or MCU reset, because RSG uses abbreviation and signal names, that kind of thing.
Cool.
Okay, that should do it. And if someone out there knows whether we should or shouldn't connect ground detect to ground, do comment down
Ground
in the
defect, right?
doobly-doo with comments. Ground detect. Sorry, yes, pin 9.
I believe that is what ended up working for us.
That also works for me.
Header.
Ditto.
And it did not work until we did that.
Oh, okay, cool.
But don't take my word as gospel. I have very not a ton of experience working with bare chip programming. So, anyways.
I've always connected ground for the duration I've been doing bare chip programming, and that's connected ground to ground detect. So, what is next? Oh, rotating the chip, seeing where data plus and data minus are. As well as we need to then surf through the SEERCOM pinouts to figure out what we want as far as SPI to the display.
So we're coming back to the schematic and making those connections. Now we've added those nets. Now we're getting errors because this room came in. So, cool. So now let's find out where those are. So here you go. You've got your SWs right here. You've got your reset right here.
So let's rotate that pointing downwards.
I agree.
Where's data plus, data minus?
Data plus, data minus. How did I know?
Awesome.
That's convenient.
So we could consider putting the MCU in the bottom right-hand corner and then peppering the stuff around it.
Sure, the bottom right. Yeah, that makes sense.
Not all the way, of course, because we have mounting hole and higher than that even. We have mounting hole. Oh no, not higher. Sorry, I forgot the program headers on the other side. My bad. But we'll want routing room for other things and passives. And, can you tell me where V is on the chip? Because we're going to need to throw some capacitors on that. If not, we're going to need to put some other components as well.
Yeah, let's find out. So here's 3.3 volts and ground are right here. There are some other things I've connected to ground all around it. So there's one on that side. There's all four sides.
V-core, yes, that's one thing about this chip. V-core is on pin number 53.
53. So that is over here. 53. Whoa.
Okay.
That is not
so, connected. Well, we haven't connected it.
Right.
Yeah. So I say we're just going to put some capacitors on there. But if you are going to make this design for yourself or you want to enhance upon it, the datasheet, dig deep and figure out how to do the switching regulator version, which I believe also requires some fuses to be set. We're doing this because it's quicker and for tutorial purposes, just workflow purposes, that's what we should do. But if you were to take this and refine it, or if you were to do like 2 prototypes during an STP, take that as a refining step to add that last polishing touch. And I will find the capacities we need for that. Give me a second.
And while Jay looks into that, so I'm going to talk about, you see this crazy, it's actually called the rat's nest. It is all the connections that are going around, and it's pretty nuts. And it can be distracting. So when you click and hold on a part, you'll only see the rat's nest that pertains to that part, but you'll see that it's moving around. And the reason it's moving around is because obviously a lot of parts can connect to the same net. For example, ground is going to be connected to tons of different things. So we want ours to be generally somewhat close to where they should be going, keeping in mind that traces that curl around each other are going to introduce parasitic capacitances and inductances that can sometimes matter depending on what you're doing. Probably not too much for most of the things in this design, but if you're doing anything that operates on a high frequency, you do need to consider that and try and keep your traces as short as possible between components. So I'm going to put my MCU reset right near the actual MCU reset of this chip. And one thing you're going to notice is that I ignore the ground rat's nest, and I'm doing that for a reason. At the end of this project, this tutorial, we are going to do something called a polygon pour, which is where we tell Altium to finish filling in all of a certain net by pouring exposed copper across the entire board. So that means every exposed ground connection is going to end up touching the rest of the ground. I don't know if I explained that well. Let me try again. All of this dead space in between the components at the end is going to be automatically filled in with copper, and we can connect that copper to the ground for every component that has a ground, and that way we don't have to actually wire ground routing, which saves you some time and makes it easier to route everything, because I don't want to have to worry about a ground wire crossing through here and possibly interrupting other traces. So I just save it till the end, and that's my advice to you as well. Save the ground and even VCC for the end.
So we're going to put 2 capacitors on there, a 4.7 mic and 100 nano.
Okay, let me go in and add this. So do we have similar capacitors anywhere already?
Yes.
100 micro, 4.7 microfarads.
I believe that's on the battery.
Yep, right here. Let's use that one. And 100 nanofarads. I don't think we used one of those yet. Or do we have one? Oh, I better check. It's a 1 micro, it's a 1 micro. No, I don't think we did. Okay. So let me add that. And I need to get rid of some panels. So I'm going to write ceramic capacitor. I think we're using 0603 100 nanofarads. And there I go. And we're good to go. Let me change this thing's name. 100 nanofarads. And these are going on VDD core?
Yes. VDD core to ground.
Alright, let me make some space for this. I think we'll just wire these switches in with net labels. Looks like they got offset 50 mil somehow. Hopefully that's fixed. So I'll just put them down to the side for a second. Whoa, wrong button. Then I will grab this, move it over, and try and make some room for this. Could have done a better job, probably, of arranging things, but that's okay.
What do you mean by that?
Just don't have a ton of room right now, but this looks good.
Ah,
And this isn't this is a ceramic fast for both of these, right?
yeah. Actually, they should be. These have to be. Um, and when I say if you make this and want to expand upon it, you should convert to switching. I really do mean that. It is. It would be a great thing to learn. Additionally, it seems like most microcontrollers that are coming out, like modern ones, uh, recent ones, are slowly switching to that for internal regulation, which is kind of cool to see. Vertical integration in the industry. But and okay, so that should also give us some component placement. What else do we need?
Cool.
Oh, I believe we've ran on for 2-ish hours with some interruptions. Do we want to pick up here next time?
Continue next time. Seems like a good place to stop.
Hmm.
Let me finish this episode just by importing those components, and yeah, import changes. Don't add the room, validate. Gonna get issues because they're unknown pins because the parts don't exist, and then all of a sudden they do. And that's it. Oh, I made a mistake. I didn't actually annotate those capacitors, so that's no good. We can't have that. Let's fix it. We'll come in here, tools, annotation. I knew I forgot something. Update changes. 2 changes were made. Now accept them. Now we save the file. Now we import those changes. Cool. And that's that.
Awesome.
There we go. And we know those are going right next to that VDD core. Hard for me to stop when I get into the Altium flow.
I know what you mean, but I think for sake of planet, we have some things we need to sort out that we should do before diving right
Yeah,
back in.
I agree. So can we at least mention what those things are, so that because I think we're gonna work on them, not necessarily recording it, and then we'll come back with whatever decisions we make.
Yeah. So I think we need to give a little more consideration to the mechanical placement of the USB-C port and buttons. Additionally, we're going to spend some time scrolling through the datasheet and figuring out what SIRCOMs would be best. So what I mean by what SIRCOMs is chip specific, or rather vendor specific. So this is a microchip part, used to be an Atmel part. And what's cool about the microchip and PIC series is that they have these serial communication blocks inside of them, and each serial communication block is hooked up to specific pins. But any SIRCOM block can be configured to be an SPI port or an I2C port or a UART port. And what that means is it's very versatile, so that you can have any number between 0 and 6 SPI port, but you trade off between SPI, I2C, and UART. Um, so this chip has 5 of them easily exposed, and we'll go through and we'll figure out what we want. We'll also read through the data sheet of the display and choose exactly what we want for input output. And did I miss anything?
No, I think that's exactly what we're gonna do, and then when we come back,
Maybe a touch of chassis CAD, but
yes,
that
we should talk
no
about
promises, no
doing
promises.
that, and I think we might as well record that since we're gonna be doing
Yeah,
it
we can always,
anyways.
yeah,
So there might be some Fusion 360 tutorials upcoming, and then we'll finish placing components and do some routing.
awesome.
Cool. All right. Well, thanks.
See you all later.